Hello, this is another exercise where we are asked to design a context-free grammar for a language. This language is the set of strings composed of the letters A and B, for which there are more A's than B's. For example, we will accept uh, just one A, multiple A's without any B. However, when there is a number of B in the string, there should be a number of A, and this number should be greater than the number of B. For example, here we have 4B and we have 6 A's. Here also we have 4B, but now the B in the beginning, and we have 5A. We don't have any problem with the place of the B, but the number of A should be greater than the number of B. For example, here we have a list of A followed by 2B and then a list of A. It's okay since the number of A is greater than the number of B. Also here we may have a sequence of A followed by a sequence of B, followed by a sequence of A, followed again by a sequence of B. It doesn't matter the order of the letters, but what matters here is the number of the occurrences of A and B. Take, for example, the last string here. We have BA, then BA, then BA, triple A, triple B. And now we have double B, so the total is 5B with 3A. So we have added here 3A so that the number of A exceeds the number of B's. Now, to find the context-free grammar that may generate all of these strings, we need to think about the rules, how any example of these strings can be generated by the grammar. So the best way here is to pick up all the strings and think about how are they decomposed. They are composed of what exactly? How can they be generated from a grammar, for example, that starts with the symbol S? As you may see here in the examples, every string is either a list of A's, one or more A's, or there is a part with a balanced number of A's and B's, and another part which contains only A's. Okay, each string can be seen this way. A number of B's with the same number of A's, so this is the balanced part, and another part which is composed of just A. Also here we may see, for example, that we have double A, double B, a balanced number of symbols A and B, and before it and after it we have any sequence of A's. For the last string, for example, we can see that it's a balanced string, BA, 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 for example, 3A and 3B, and after it, again, another balanced string, double B, double A. So this is the part 1, this is the part 2, and the part 3 will be just 1A, for example, or more than that. So we will write here the forms, the different forms of the strings that would be accepted. So it will be a list of A. I am noting here A's, and it also may be A's followed by a balanced string, like this one, for example. I have a balanced string here preceded by a list of A's. It may be the reverse, some balanced string followed by A's, a number of A's, and also it may be a number of A's followed by a balanced string followed by A's. It may also be A's, then balanced, then A's, then balanced, then A's. So any occurrence of these patterns will be accepted. So if string here will be unaccepted string, we can say that it may be a list of A's or a balanced substring followed by a string with the same pattern of the original string, or also we can say that it will be a string in which the number of A's exceeds the number of B's, followed by a balanced string, followed by a set of A's. In this way, we optimized the rules, and we can find all the other rules from this one. Let's assume here that if the string is composed of only A's, there should be a minimum one A. So it will be one or many. But here we may have a string followed by a balanced string followed by nothing. We may end by the balanced string, and also we may end the string here by a list of A's. And now we may clean up the rules here and say that we may write these three non-terminal symbols S and A and B, with S that will contain the strings with more A's than B's. A will yield to 0 or more A's, and B will yield to a balanced number of A's and B's. Let's say here for S, so it's one or many symbols A, or it will be a balanced string concatenated to another string, or it will be a string concatenated to a balanced string concatenated to a list of A's, where A is 0 or more small a, so it's A or epsilon. For the balanced string B, it should be written as follows. With each A, there is a B. So if we start with A, we will write A capital B, B. If we start with B, we will write B capital B, A. And also we need to add this rule. Each B can yield to twice as B, B concatenated to B, in order to accept, for example, this kind of balanced string. B, we start with B and we end with B, and in the middle we have double A. So we have here a balanced number of A's and B's. Of course, here, since each B will lead to a rule with another B, here or here or here, we should end this recursion by adding epsilon. The last B will yield to epsilon. Now let's prove that this grammar generates the correct strings. For example, let's take AAA double B. Here we will draw a parse tree. So here we will apply the first production here. We will apply S derives SBA. We will obtain the string SBA, for which this S will yield to AA according to this rule. Then for this B, we will choose B derives ABB. Then for the second variable B, we will choose again A derives ABB. Then the last B will yield to epsilon. Here this A will yield to epsilon, and we will find that the string A, B, B is generated by this grammar. Now let's take another string, B followed by 4 A's. For this, we can first choose the rule S here yields to BS. And then we will have this variable B. We will choose B produces BA. And for this B, it will be epsilon. We will apply the last rule. Here for this S, let's say that we will choose the rule AA. S derives AA. For this A, it will be again A derives AA. And for this A, we will choose AA, and the last A here we will choose epsilon. Now we have our string in the leaves of the parse tree, B, A, 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 A. The last string will be B double A, B, four A's, followed by another B. So we will first choose the rule S yields to BS. Then for this B, we will choose B yields to BB. For this B, it will be substituted by BBA, and the B in the middle will be substituted by epsilon. Here for the second B, it will be ABB, and the B in the middle will yield to epsilon. Here the first part of the string has appeared. Here B A A B. We have now to show how to generate this string from this variable S. So we will choose S yields to SBA according to this rule, and for this S it will yield to AA, and then this A to AA, and then the last A will yield to epsilon, and this way we have shown how to parse the triple A here in the middle. Now for the last part, AB, it will be obtained from this variable B. So we'll choose here this rule, B yields to A, B, B. And now this B will yield to epsilon since the A and the B have already appeared. And finally here, this A will lead to epsilon. And finally, we obtained the string in the leaves of the parse tree, B, A, B, a triple A, then another A, and a last B. That's it, and thanks a lot.